Hi folks, this is activity W3P1 and it deals with creating a slider crank mechanism which was already done incidentally in the activity labeled W2P0. And for those of you who are in my class, I'll also sent you the parts, which are very simple here. But I said, don't worry about making it. I'll send you the part, and then you create the assembly which represents this problem. Uh, so in this particular tutorial, W3P1 that you're watching, you're going to put some physics into that, okay? Irrespective of what the dimensions are, I'm going to assume that the angular velocity of the crank or that cylindrical joint that you see there, for example, is uh, uh, let's say 60 RPM. Incidentally, I noticed that down here it says this is a cylindrical joint, but the way I did it in class for the earlier uh, W2P0 activity, I made it a revolute. It really doesn't matter. Okay. Uh, all right. So let me go ahead and use those same things, bring those parts into my product. Now, I'm not going to bother doing them in this tutorial because it's already done. So I will bring them in, insert existing component in that folder. And it says where. So I believe that that is, I can find it somewhere. Let's see if I can find it here. Uh, so that is week 2 activities. There we are. So I'm gonna bring everything but the uh, product. Okay, so let me do it one by one. So let's bring this thing here. So insert existing component again in there. So I'll do conrod, crank, not the product. There we are. And then insert the last piece, that's the track. So insert existing component in there, and I'm gonna bring the track. Okay, so we're good. All right. Now, notice that there are no constraints here. So what I'm going to do is, first thing is I'm going to fix the track, and I'll move things apart. And my way of doing moving things apart is by using the move icon, manipulate toolbar. Okay. And let me do a little bit crazy rotations here so that not everything is lined up. Okay, very good. Now, why don't I put this crank in that shaft? So coincidence. And again, the different ways of doing these things, but I'm going to do this plane and that plane. Okay, and coincidence between this axis. See if I can zoom in. This axis and that axis. There we are. Okay, now let's put this connecting rod in that hole. So coincidence between this axis and that axis, and coincidence between this plane and that plane. And if things don't look good, either flip the arrow, which is equivalent to saying changing this from same to opposite. There we are. Now let's place this block on that track. So coincidence between this edge and that edge. Okay. And why don't, because later on I want to create a prismatic joint, I also do coincidence, which doesn't seem to well, it is needed because look at look at what I can do. I can say that okay, why don't I rotate about this axis? You see, this can happen. I don't want that thing to happen. So what I'm going to do is a coincidence between this plane and that plane, and now you cannot rotate. Now, finally, I'm going to put that shaft in that hole. So coincidence between this axis and that axis, and as long as they line up, you really don't need to make that revolve. So what I did in class, I showed you that, okay, you can check your stuff. For example, you can say, all right, manipulate, make sure that this check box is check, this box is check, and then, for example, rotate about this axis, look at what happens. So this is an indication that probably everything is okay. But this is not a mechanism. It's just that, constraints have been created. Now we're going to go to digital markup, DMU kinematics. Since we already have some constraint, hopefully they're good enough to do our problem. Click on the magic wand here, assembly constraint conversion. It's a new mechanism number one, and automatically create all the joints. Look, right now I don't have anything as far as, but as soon as I say auto create, it creates 4 joints for you. Prismatic, obviously, cylindrical is this last one, revolute and revolute, and say okay. Now, this is a single degree of freedom system. That means that if I make, for example, this revolute joint angle driven, that would be, is it between conrod and the crank? No, it's this one, revolute crank and the track. Yeah, that's the one. If I make this thing angle driven, it says mechanism can be simulated, and I can check it out. And notice that as you turn this thing around, this thing goes, as it's supposed to. So everything looks good, except that there's no physics here. I can go and create simulation. For example, I can make uh, cartoons for you, as I will do later on in your next activity, or you will do in your next activity. But I want to put some physics into this thing. So here's the situation. Uh, the first thing that we do is we go to, see here, there's f of x there in the knowledge toolbar, f of x. Click. Okay, so it shows you everything that is in your database, but I'm not interested in everything. I'm just interested in the mechanism. You click on the mechanism, there's just 2 things, time and the angle. How does the angle, this angle-driven joint, remember, changes with time? So you select this, and you say add a formula, equal to. So here it says this angle equal to, well, you decide how fast you want to go. For example, if you want to say 60 turn underscore MIN, or you could have typed 360 DEG underscore second, that's the same thing, times time, variable time. See if you can find it right there. So that tells you that the speed of the rotation of that crank is 60 turn per minute, or 360 degrees per second. In 1 second, it goes once around the shaft, around this shaft. Say okay. So no syntax error, everything is okay. We say all right, and notice that a law has been created right there. Okay. All right. And now what you want to do is go and do simulation with laws right there. See that? Simulation with laws. Simulation with laws. Now, before I do that, I want to create some probes here, because I want to know, for example, what is the velocity of this point? What is the velocity of the center of the connecting rod, etc. In order to do that, I don't need it for that point because it's already a corner point. But if you want the velocity of some point, for example, so you need to create a point on this connecting rod. In order to do that, make sure you go to the connecting rod and create a point. There is a point, and the method is on a plane. And for the plane, you select that face of the connecting rod, and it doesn't matter where. For example, somewhere there. That's the actual location is not important to us in this tutorial. Okay, you're not asked to select a specific point. It could be halfway between the 2 ends, but anyway, that's what it is. And when you're done, you go back to the digital mockup, DMU kinematics, and create a sensor right there, speed and acceleration sensor. I'm going to do three of them. One of them is going to be that corner point. Let me see now. First of all, reference product for, I'm going to do this corner point with respect to the track. So for reference product, you select the track, and for the point, you select that corner point. And I'm going to call this thing block corner with respect to track. Okay. And then we say, okay, let's do another one. This time I'm going to select for reference product, once again, the track. But for the point, I'm going to select this point on the connecting rod. And I'm going to call this thing point on conrod with respect to track. Okay. And then we say, okay. And finally, I'm going to do another one, which is going to be the reference product is going to be the block. The point is going to be that same point that I created here. You see this? And I'm going to call this thing uh, point on Conrad with respect to a block. Okay. And yep. So, okay. Now, notice that these are created here. So we want to do a simulation over 3-second interval. So let's go ahead and click on the simulation with laws, and we select 2 seconds and activate sensor. It says, okay, you asked me to create 3 sensors. Tell me, what is it that you want to see from those 3 sensors? So the first one was with respect to the corner point of the block, right? So we go and find the velocity, linear speed, magnitude of the linear speed, block corner with respect to track. Then we scroll down, we find point on Conrad with respect to track. That's this one, select it. And you scroll again down, point on Conrad with respect to the block, which is going to be further down. And it's the linear speed that we're talking about. Now, don't change anything else. Okay, just move this thing down, and go and run it. Okay, and wait until this thing finishes. When it finishes, go back here and say graphics. So it gives you 3 curves. These 3 curves are those 3 locations with respect to 2 of them with respect to track, 1 of them with respect to block. So let's look at the block corner point with respect to the track. Is this yellow one? And some complicated, periodic oscillation. You can read the units. This says inch per second. If it was meter per second that you were asked to do it, you go and change the unit. These are very important for the exams. Okay. Now, the other one is the next one is the point on the Conrad with respect to. Let's look at the green one with respect to track also. So that's the green one. Now, the point on the Conrad with respect to the block, notice that it's different from with respect to the track. And when you think about it, it makes sense. What it's saying is that this point, move this thing out of the way, this point, velocity of it, with respect to the magnitude of a velocity with respect to the block, which obviously is not going to be with respect to the track. It's going to be different functions. In fact, when you think about it, this point goes around a circle here, not at a constant speed. We know that. Definitely not at a constant speed. And that's why you get some complicated, variation. as you expect. So anyway, let's now suppose you were asked to generate these things and you were asked to submit it as part of your exam. First of all, generate only the stuff that I asked you to do. And then, unfortunately, this you have to screen capture it and save it as an image and submit it with your work. For example, in my case, the screen capture is well. Let me do a print screen. It's a print screen. Okay, so you select this. Okay. For example, you can start with a PDF, well, a PowerPoint or Word document. Doesn't matter, whatever you want. Where's the delete? Delete, paste, save as. That is in my folder that you're going to submit as, for example, exam folder, whatever it is. And it was called, see if I can find it here. Yeah, that's the one. Week 3, problem 1. So it's my 3 velocity versus time. Save it and make sure that later on the test, when you upload your work, you also upload this particular PowerPoint. Okay. Or if it was a Word document or a PDF. Anyway, you won't be able to save this thing in your work. Okay. When I open your work, I cannot see this. You have to capture the image somehow. Now let's go back here. Suppose you were also asked to create another graph, which is the velocity, for example, of the corner point versus the velocity of the point on the conrod with respect to the track. Now you have asked for these two, both of them with respect to track, but this velocity versus that velocity, not versus time, this velocity versus that velocity. First of all, you must have created, you must have asked for it and created it, and you have, because you're plotting it. Then you can close this. All right. Then you go here under options. See that? Not graph. If you say graph, it gives you that. We don't want this thing. Under options, it says you want a customized graph. Select on the customized radio button. Add. It says, okay, what do you want to plot against what? You must have asked for it to begin with. And let's see now. I want corner point of the block. Let's see. Block corner point, linear speed versus point on conrod linear speed. If you have not asked any one of these, you will not be able to generate this plot. So let's see, linear speed right here. Block corner point with respect to track, and oops, not this one, not block. Point on conrod with respect to right here. Point on conrod with respect to track, and block conrod with respect to track. And then you say, okay, all right. And then that's curve number 1. And you close it and you graph it. There we are. Zoom out so that I can see your scale. You can generate other graphs. Make sure you screen capture this. Close it. In my case, function print screen. I'm going to select. Go to that PowerPoint. Insert a new page. Home, paste. Okay, and write down here, if necessary, what is it that you're plotting? What is it that you're plotting? Or the same thing down here. Okay, and save it. So what you're going to Submit is going to be this PowerPoint with these 2 pages on it, and you're going to get marked accordingly. Now, one more thing I want to do is, suppose you were asked to generate, let me close this. Suppose you were asked to generate the trace of this point. Now, to do that, first thing that you need to do is to compile. You need to compile this. Because look, there is the icon for the trace. Where is that footprint? Right there. You click on it. Element to trace out, okay, is this point, okay, and the reference product 1. Say okay, and it generates it. Okay, you don't need to compile. Now, there's 2 ways you can do it. You can, for example, save this thing, file, save management. This everything else is saved, but trace, save as. Are we in the right folder? Nope. Which one was the? I think that's my desktop. The folder that I have is January 18, W3, week 3 point problem 1. Yep. So I call it trace. I say okay. Cancel. Let's read this thing carefully. The following document will not be saved. Okay, fine. That's fine. I understand. Good. Let me close this, because now I can say insert the existing component in there. There's my trace. Bring it up, and I can see it. So why is it that I can't see? Let me see. Did I put it in there? Oh, track. That's not what I wanted. Sorry. Insert. Mistake. Insert existing component in there. I want to trace, not track. Why was it? Oh, that's not the right folder. That's what it is. Where was my folder? It was right here. Trace is right there. Hallelujah. Please make sure you put the stuff in the right folder, systematically save your work, etc. So I showed you how to generate plots versus time, one variable versus another variable, customized graph, and the trace. And one way is to save the trace and then insert as existing component, or save the trace and I can bring it up for you. All right, folks. So that's pretty much it. Good luck.